So under the urine formation, you can see that there are three basic processes are involved. And these three basic processes are known by the name glomerular filtration. What is the filtration that is taking place in the glomerulus is known by the name glomerular filtration. And what is a glomerulus? We have seen that last class. Because within the Bowman's capsule there is a cup-like structure. And in that cup-like structure we are seeing a group of blood capillaries, and this is the glomerulus. This group of blood capillaries or ducted blood capillaries we find inside the Bowman's capsule, which is known as glomerulus. The filtration of blood is taking place in the glomerulus is known by the name glomerular filtration. So that is the first event in urine formation. So in our body, the urine is actually filtered from blood. Blood will be carrying a lot of waste particles or waste material like urea, uric acid, ammonia, etc. The blood is moving through or passing through the kidney. The nephrons in our kidney will be removing or filtering this waste material. And that process is what we call excretion. So in the issue of excretion, it is taking place in number of steps. The first step is filtering or removing this waste material from the blood. And the first process is called glomerular filtration. So when blood is passing through glomerulus, lot of blood will be filtered, and a lot of water, lot of filtrate will be produced also. So and that process is known by the name glomerular filtration. Here you can see that. So this is how the glomerular filtration is taking place. This is the blood capillary or glomerulus or a blood vessel. When the blood is flowing under high pressure, lot of the water portion or plasma of the blood will be filtered from it into the narrow spaces, into this space known by the name capsular space. And that process is known by the name glomerular filtration. Now here you can see how much amount of filtration is taking place. You can see that approximately 180 liter of filtration, filtrate is produced. That is, we have two kidneys. Together both kidneys will be filtering around 180 liters of filtrate. That is, only we have 5 liter or 2.5 liter of blood. There is several times this blood will be passing through the kidney. Each time a lot of filtrate will be removed. So that if you take a total volume, that will be coming to 180 liter. So 180 liter of filtrate will be produced or filtrate will be produced. Out of that, our urine output in a day is around 1 liter or 2 liter. So that means out of 180 liters of filtrate produced, major portion is again reabsorbed by the body. And as I said, only very little urine is finally produced. That is, what is lost in the form of water in the form of filtrate is coming to 1 liter or 1.5 liter or 2 liter. The remaining portion, that is out of this 180, 178 liters are actually reabsorbed or taken by the body. And that is 99% of the filtrate is reabsorbed. So that is coming to we are coming to the second process in that. And that second, so here you can see that this much amount of filtrate is produced. Out of that, final urine will be around 0.6 to 2.5 liter. That is a maximum. Normally it is 1.5 liter. So these are the different factors which are influencing the glomerular filtration. Normally blood pressure, if the pressure of a person is higher, that means more amount of filtrate will be produced. So then any kind of obstruction to the urine flow, hormonal control. So these are kind of some of the factors which are controlling it. And there is also a structure known by juxtaglomerular apparatus. Here somewhere here you can see that. I think there is a structure called juxtaglomerular apparatus. Purpose of this juxtaglomerular apparatus is also controlling the filtration, control the blood flow in the glomerulus. That is or controlling the filtration of in the glomerulus. That is the main function. Here you can see that. See, this is the juxtaglomerular apparatus. His function is also controlling how much amount of blood is filtered. Then we are coming to the, here also you can find this is the juxtaglomerular cells. Then second process is known by the tubular reabsorption. Why it is here already we have seen that 99% of the filtrate will be reabsorbed. And only 1 liter or 1% or less than 1% is finally eliminated or removed from our body in the form of urine. Now that means majority of the substance like water, majority is containing water. Then many useful substances are there like glucose is present, amino acid will be present, urea is present, ions are present. Then sodium ions are present. All these substances will be reabsorbed by the body. For example, it is in this region this glomerular filtration is taking place. And the filtrate will be slowly moving through this tubule and finally reaching the loop of Henle. Both in this tubule as well as in the loop of Henle, major portion of the water as well as glucose, amino acids, etc. will be reabsorbed by our body. And that process is known by the tubular reabsorption. Why we call it as tubular reabsorption? Because they are taking place in this tubule. In this tubule. That is why we are calling it is in this tubule. This reabsorption of filtrate is taking place. That is the reason why we are calling it as tubular reabsorption. So that is the second event or second process which are involved in the urine formation. The first process is what is called glomerular filtration. Out of that 180 liters of blood will be filtered. And during the second process, major portion of this filtrate will be retaken or reabsorbed by your body, and that process is known by the name tubular reabsorption. And what are the substances which are reabsorbed? Mainly water, glucose and amino acids. So these are useful for our body. Whereas some substances like urea, they are not needed by our body in large quantity, but still they are reabsorbed. Then certain other substances are also like sodium. Sodium will be also reabsorbed. Then we are here you can see that how sodium ions are reabsorbed by active transport. Active transport means for reabsorption of sodium, our body has to use some kind of energy. Some energy pump has to be operated. So with the help of utilizing energy, sodium ions are actively reabsorbed. Then certain negatively charged ions are also reabsorbed in here you can see that sodium, this is the urinary tubule, this is the blood vessel. Okay, here you can see the sodium is moving out, that is sodium is reabsorbed. Then you can also see that chloride ions are also reabsorbed. Next, phosphate ions are reabsorbed. Then bicarbonate ions are reabsorbed. Then you can see that water is reabsorbed. So these are the various substances which are reabsorbed. Coming to water, this reabsorption of water is mainly taking place by osmosis. What is osmosis? Where there is higher concentration of water will be moving from that area to an area where there is lower concentration of water. Here there is more concentration of water or more volume of water. So naturally water will be moving to an area where there is lesser concentration or lesser volume of water. So these are the different mechanisms by which we are finding this tubular reabsorption is taking place. So sodium ions, chloride ions, phosphate ions, bicarbonate ions and water are the substances which are reabsorbed into the blood vessel during the flow of filtrate of the urinary tubule. Then next step is here also the same picture. This is the glomerulus filtrate. What the filtrate will be moving into that. During this process, many useful substances will be reabsorbed into the efferent arteriole or blood vessel, and finally taken into our blood vessel, heart itself again. Then next step is that there is another. That is, here you can see how much amount of water, that is 60 to 70% of water and sodium will be reabsorbed, 100% of glucose and amino acid will be reabsorbed, 90% of potassium ions, bicarbonate ions, calcium ions and uric acid will be reabsorbed. So these are the various kind of substances which are reabsorbed as a result of tubular reabsorption. Now, one important structure which are involved in reabsorption is the loop of Henle. Here we can see that this is the loop of Henle. This structure is known as the loop of, this is the loop of Henle or Henle's loop. And this Henle's loop is the primary area where this reabsorption of water and glucose is taking place. So it is playing a very important role. And there is one hormone is present known by the name ADH, anti-diuretic hormone. When this hormone is present, when body is secreting this hormone, more amount of water will be reabsorbed. That is, higher the release of ADH, higher the amount of reabsorption. So there is a direct relationship between secretion or presence of ADH and amount of water which is reabsorbed. So higher the ADH, more will be the reabsorption. So that is the importance of loop of Henle. Here you can see that, and loop of Henle is how loop of Henle is helping in the reabsorption of event. Then another area which are involved in reabsorption is the distal DCT. Or distal convoluted tubule. What is DCT? This structure is known as a DCT. See, this is the Bowman's capsule. First there is a coiled or convoluted region which we call proximal convoluted region, followed by what we are seeing is the loop of Henle. Then there is another smaller convoluted region here which we call as the distal convoluted region or simply DCT. And DCT and this tubule known by the name collecting duct. These are another regions which are involved in the reabsorption. So distal convoluted tubule as well as collecting duct are also playing an important role in the reabsorption. And what are the substances which are reabsorbed? Basically calcium ions. And here there is a hormone is secreted by the body called aldosterone. And this aldosterone is affecting the reabsorption of sodium ions and potassium ions. So then also water. So earlier we can see that in the here it is ADH which is responsible for reabsorption, whereas in the case of DCT as well as collecting duct, it is the presence of aldosterone which are mainly controlling the reabsorption of or regulating the reabsorption of sodium ions, potassium ions as well as calcium ions. So that is another point regarding the reabsorption. Here also you can see another picture. This is actually very detailed slide, primarily produced by someone else. I have taken it from the, but the pictures are very clear and that is why I am also using it. Then distal convoluted tubule has another function that is known by the tubular secretion. That is, many substances like potassium ions, hydrogen ions, urea, ammonia, creatine and some amount of drugs. They will be actually pumped back. Here you can see that this is the blood vessel and this is the urinary tubule. Here also Here, see, this is how the all structure is here. See, here you can, this is the urinary tubule and this is the blood vessel. Here you can see the arrows are shown in this direction. That is, when blood is flowing through the efferent arteriole, certain substance will be pumped back into the urinary tubule again. These substances and that process is known by the name tubular secretion. It's simply secretion of certain substance. What are the substances which are secreted back into the urinary tubule? And these are the substances which are secreted back into the urinary tubule. They are potassium ions, hydrogen ions, urea, ammonia, creatine, and drugs. So when when urine is flowing in that tubule, the blood vessel is also lying very close to it, and because of that, certain substance will be re-pumped or will be pumped back into the urinary tubule, and this process is known by the name tubular secretion. That is known as a tubular secretion. And secretion of hydrogen ions is also an important event taking place in the tubular secretion. Here you can see that basically some substance will be taken from the urinary tubule into the blood vessel. That process is known by the name tubular reabsorption. Whereas some substance will be taken from blood vessel and pumped into the urinary tubule. That process is known by the name tubular secretion. Basically, these potassium ions and hydrogen ions as well as little amount of ammonia as and creatine are also involved. So this is how two important processes are taking place. One is tubular secretion and other is tubular reabsorption. So as a whole, the urine formation, the formation of urine has three events. One is glomerular filtration, and second event is known by the name tubular reabsorption, and third event is known by the name tubular secretion. And it is by these three events that our body is able to produce enough amount of urine. And if there are some complication in any of these processes, sometimes if your kidney is damaged, if there is, for example, the person is having severe blood pressure for a long time, what happens is that these glomerulus are very small blood vessels. They can break or rupture. And this breaking or rupture of blood vessels can result in damage to the kidney. And when this process of slow damage is continuing for several years, 10 years or 20 years, finally our kidney will stop working. Then what doctors say, your kidney is no longer effective. You have to either replace a kidney or transplant a kidney, or you have to take daily what we call dialysis. So that is the only solution. So any kind of damage that can happen here, it can ultimately result in the damage to the kidney, maybe death also. Then, and there is another event here. Here you can see that the loop of Henle. This loop of Henle has two tubes. One is going in the downward direction, the first tube. So the fluid is going in the downward direction. Whereas if you take the second tube, the fluid is moving in the upward direction. Okay, and there is another tube where the fluid is that is collecting duct. Collecting duct is also very closely present to the. See, this is how. So here this is the descending limb. This is the ascending limb, and this is the collecting duct. Okay. So here what we are seeing is that there is a direction in the flow of fluid or in this loop of Henle as well as collecting duct. And fluid in this tube is going in the downward direction. Okay. Fluid in this limb is going in the upward direction. And this kind of opposite movement is actually helping in this tubular reabsorption and tubular secretion to a large extent. And this process is known by the counter current system. So what do you mean by counter current system? In the first limb it is in the downward direction, and the second limb it is in the upward direction. So it is opposite direction. and this is known as counter current system. So these are the various processes and phenomena which are involved in the urine formation. Sometimes in last question paper also they have us give an account of the urine formation. So you have to explain all these things by drawing the diagram of a nephron. So that is regarding the first one. Then